After reading the problem, we would look at the equation. Our first step would be to find K. So we would need to plug in all of our knowns. T, the constant temperature of the room, which we found is 70. U, which is the initial temperature of the object, which the average temperature of a human body before death is 98.6 degrees, minus the constant, times the natural log of our two unknowns, the decay coefficient, along with the time since discovery, since we don't know what the time of death is. We would simplify this down to 28.6. To find K, though, you would have to have two separate equations. One of them equaling 80, because at 6 p.m., the time of discovery, the body was 80 degrees. Down here, it would be the same thing, except for T would be plus 1, since it was exactly 1 hour after the time of discovery, which is when the body temperature was at 75 degrees. Now, you would just subtract the 70 from this side, and you would get 28.6 times the natural log of negative KT equals 10. And you would solve down here, subtracting the 70, making this 28.6 times e to the negative k, which would have to be distributed amongst this number. So it'd be negative kt minus k equals 5, which would require more work, because then you would separate 28.6 e to the negative kt from the natural log of e to the negative k. Because they're together, they can be multiplied, equals 5. Now we see in this equation that this problem equals 10. So for this, you can substitute in 10 times e to the negative k equals 5, which then you would just divide the 10 out, making this 1/2. Taking the natural log of both sides would leave this as negative k times the natural log of 1/2. Because the k is a negative, you would flip this number to make this the natural log of 2, which also equals 0.693. To find part B, the time elapsed from death to discovery, we would choose one of our previous equations, either 1 or 2, and I'm going to choose 1. And then you would plug all of the known numbers back into the equation. So the equation would still be 70 plus 28.6 e. Now you know k, which is negative, and I'm going to use the unsimplified version of ln. So I'm going to use ln2 times t equals 80. And now you're going to simplify this by subtracting the 70 out. Making this 10. Now, to divide by 28.6 would make this e to the negative ln2 times t equals, in a simplified version, would be 50 over 143. Take the natural log of both sides, and you're left with the natural log of ln 50 over 143. Now you would divide this number by negative ln2, which would ultimately get t equals 1.5 hours since the time of death to the time of discovery. To find the time of death, you would subtract the hours from 6, the time of discovery, which would ultimately lead to 4.5. Since these are the hours are going to remain at 4, and 5 times 60 minutes, since there are 60 minutes in an hour, is going to equal 30, making the time of death 4:30.